We're going to be solving more trig equations in this video involving multiple angles, okay? Starting with this one up here, it says solve the equation tangent of 3x equals 1 for all possible radian solutions. So all possible solutions, not just between 0 and 2 pi, but every single one. And also check this graphically. So let's go ahead and take a look at what we want to do here. First things first, let's get the trig function by itself. And what I notice is tangent of 3x is already by itself. So I get this. This is equal to 1. To undo the tangent function, what we'll do is we'll do tangent inverse of both sides. So we say tangent inverse of this, tangent inverse of this. And so these cancel out. We get left with 3x equals the tangent inverse of 1. Okay, so now we need to figure out what angles these actually are. We say tangent inverse of 1. Well, 1, the tangent inverse of this would give me a 45-degree reference angle. So what this does is it presents us with a 45-degree reference angle. So sketching this out, we say, well, 45-degree reference angles, they look like this. Okay, all of these here, we would say would be 45 degrees. So we want to know what trig function, or sorry, what quadrants were we in, or what angles were they that gave us a positive 1 for a tangent. Okay, so if it's a positive 1, tangent's positive, then that means we're either in the first quadrant or the third quadrant. So we say our two angles here are 45 and 225. So we say 45 and 225. Okay, so if we were doing this in degrees, we would list these in degrees. What we wanted to do was in radians. So we say this is pi force radians. That's a 45-degree angle. We say take 1, 2, 3, 4, 5 of these pi force to get over to this one. So 5 pi force. So since we're doing everything in radians now, we say, okay, well then what we get is this. We get 3x equals pi force plus, and what we're going to write here is this. We're going to say plus pi k. And we get 3x equals 5 pi force plus pi k. So the reason why we added pi is because pi is the period of tangent. Okay, and I want to make sure we write a note here on this one. Pi is the period of tangent. So what this means is we're going to add on any multiple of its period because we know it's just going to repeat itself again. So now solving by dividing everything by 3 here. We're going to divide both sides by 3. We get this. We get x is equal to pi force divided by 3. Pi force divided by 3 is equal to pi force times the reciprocal of 3, which is 1/3, which is pi 12ths. So we get pi 12ths plus, we'll just put this pi over the 3 here, plus pi thirds k. These are all possible radian solutions for that one. We say x here equals, now a third of 5 pi force is going to be 5 pi 12ths when we do that one, plus now pi thirds k. So I said I wanted to check this reasonably, graphically speaking, and we say, okay, well, we got y equals tan of 3x is this one right here, and we say also y equals 1. And so what we were trying to do was find out between 0 and 2 pi, which is right here, how many times these graphs meet. So we say all of these angles would be at pi 12ths, this is what we got right here, pi 12ths plus pi thirds k. So really when you look at this graph, we're saying if you were to add on now pi thirds, you'd be here, and you'd be here, and you'd be here. Actually, I forgot that. Okay, so we'd be here, plus pi thirds I'd be here, plus pi thirds I'd be here, plus pi thirds I'd be here. And the same thing with this one, 5 pi 12ths. We got 5 pi 12ths. But if we're adding on pi thirds increments every time, we say here, plus 5 pi thirds. See if I can shut some of these off. Would be here, plus another 5 pi thirds would land us here. Okay, so we just listed all of those possible solutions. Okay, so let's take a look at now example number 4. Example number 4. Very similar to number 3, and then we need to get the trig function by itself, except for I noticed that I have a sine squared and I have a sine. So sine squared 2x and a sine 2x. What we're going to try to do here is we're going to factor this. And so just like we've factored in the past, we're going to do the same kind of idea here, except for instead of 2 sine of x and sine of x, I have 2 sine 2x and sine of 2x. These will multiply out to be my sine 2x squared. And then moving forward, we say, well, what can I multiply to get a negative 1? So maybe I try like a positive 1, negative 1 combination. We need to check this, but it looks like I get negative 2 sine 2x and then positive 1 sine 2x. And those add up to be a negative 1 sine 2x, which is what I need here in the middle. So these are the appropriate factors here. I'm going to get that work out of the way here, but these are the appropriate factors. So what we're going to do now is we're just going to set each individual factor equal to 0 and solve. So we get 2 sine 2x plus 1 equals 0, or sine 2x minus 1 equals 0. So let's isolate the trig function here. If I subtract 1 and divide by 2, I get the sine of 2x comes out to be a negative a half. And I get here sine of 2x when I add 1 to both sides, I get 1. So now we'll do the inverse trig function of each of these individually. So we say sine inverse of everything, sine inverse. And we get then 2x equals sine inverse of 1. We'll come back to that. And over here, if I do the sine inverse of both sides, let's just acknowledge I get 2x equals the sine inverse of negative a half. So now we need to get our calculator and conceive of where these angles might be. But we'd say, okay, well, if 2x equals sine inverse of negative a half, we say 0.5 negative. If we do the sine inverse of this, we get negative 30 degrees. So we say, sketching this out here, we say 30, 30, 30, 30. All students take calculus. Oh, by the way, we'd say sine came out to be a negative here. So we either must have been here or here. So we'd say 210, or here we would get 300, okay? So we'd say 2x equals 210 plus the period of sine, and we get 2x equals 330, by the way, sorry, 330 plus 360 degrees. Okay, and then from this well, I guess we need to finish solving these. Let's divide everything here by 2. We get x equals half of 210 is 105 plus 180 degrees, okay? And then here, if we divided everything by 2, I would get x equals 165 plus 180 degrees. Okay. So now, this last equation here, if we did sine inverse of 1, we say 1, sine inverse. It's got to be a 90-degree reference angle. If you think about this, 90-degree reference angles, they either have to be up here or down here. And if sine came out to be a positive 1, all students take calculus. We must have been up here at this one. Okay, so we'd say 90 degrees. So we get 2x is equal to 90 degrees plus any multiple of its period on top of that. And if we divide everything by 2, we get x then is equal to 45 degrees plus 180 degrees. Okay, and those are all of our solutions, these guys down here. Cheers.